Find the second derivative f double prime of x for the function f of x equals secant x plus tangent x, then evaluate f double prime of pi over 6. So f of x here is made up of two terms that are combined together by addition. We can therefore take the derivative of each term separately and combine the results by addition. To find the second derivative, we will first have to find the first derivative. First derivative, f prime of x will be the derivative of secant of x, will be secant of x, tangent of x, and then times 1 for the chain rule, plus the derivative of tangent will be secant squared of x, again times 1 for the chain rule. Now for our second derivative, I'm going to want to rewrite that second term to remind us how to take the derivative of secant squared of x. That means secant x, and then the entire thing to the power of 2. Our second derivative, f double prime of x, will be, well, our first term is the product of two functions, so we're going to make use of the product rule there. The derivative of the first, the derivative of secant, is secant tangent of that x, times the second left alone, plus the first left alone, secant x, times the derivative of the second, the derivative of tangent, which is secant squared of x. So that's all the derivative of the first term. And now we have the second term, which will follow a power rule. Bring the power down, leave the inside alone, subtract 1 from it, it will now be to the first power, but then multiply by the derivative of the inside of the power, the derivative of this, which is a secant derivative, that's a secant tangent. So now we can simplify our look of our derivative here. Our first term is going to be secant x times tangent squared of x. Our second term is a secant x times a secant squared of x. That'll be a secant cubed of x. And our third term has a 2. Secant times secant will be a secant squared of x times a tangent of x. And there's our second derivative, f double prime of x. Now we want to evaluate f double prime of pi over 6. Just means to plug a pi over 6 in for each of the x's. That will give us a secant of pi over 6 times a tangent of pi over 6 and then squared. Remember that means to work out the tangent first and then square it, plus a secant of pi over 6 cubed plus a 2 times the secant of pi over 6 squared times a tangent of pi over 6. Now we want to evaluate each of these. Secant of pi over 6 is 1 over the cosine of pi over 6. The cosine of pi over 6 is root 3 over 2. The tangent of pi over 6 is the sine of pi over 6, which is a 1 over 2, over the cosine of pi over 6, which is a root 3 over 2. We have that squared. And now we can replace the secant with 1 over square root of 3 over 2 everywhere we see it. And the tangent with 1 over 2 over the square root of 3 over 2 wherever we see it. Now all these fractions within fractions, we can reciprocate the denominators and multiply with the numerator. So we have that first one here will be 1 times 2 over root 3. And then that will be times a 1 over 2 times 2 over root 3 squared. Then we have a plus 1 times 2 over root 3 cubed. And then we have a 2 times 1 times 2 over root 3 squared, and a 1 over 2 times 2 over root 3. Now we will want to simplify wherever we can. The 1 over 2 times 2 over root 3, these 2's can cancel here, and likewise for this one at the end, the 2's can cancel. We have 1 in the numerator, 1 in the denominator. So now we should be able to simplify the look. For this first term, we have a 1 times 2 over root 3, which is just going to be 2 over root 3. So 2 over root 3. And then we have a 1 over root 3 squared. We have plus a 1 times 2 over root 3, which is just 2 over root 3. And that entire thing's cubed. And then we have 2 times 1 times 2 over root 3 is just 2 over root 3. And then squared, and then times a 1 over root 3. So the first term we have a 2 over root 3 times a 1 over root 3 squared. You square the 1, it's still a 1. Root 3 squared is a 3. So 1 over 3. Plus 2 over root 3 cubed. We're going to cube the 2. 2 times 2 times another 2 is an 8. And root 3 times root 3 is a 3. And then times 1 more root 3 will just be 3 times root 3. Now for the third term, we have a 2 times a 2 over root 3 squared. Square the 2, that's a 4. Square the root 3, that's a 3. And then times 1 over root 3. So our first term, if we multiply the numerators 2 times 1, we have a 2. Multiply the denominators, we will have a 3 root 3. Second term, we have an 8 over 3 root 3. And the third term, multiply the numerators, 2 times a 4 is an 8 times a 1 is an 8 over 3 root 3. We can now add these together. 2 plus 8 plus another 8 is an 18 over that common denominator. We can then divide the numerator and denominator each other with the 3 and the 18. That will cancel down to be a 6. So we end up with 6 over root 3. So there's one way to write it, though it is possible to rationalize this, and it will actually simplify its look in rationalizing. So most likely this answer will be rationalized. Generally it's rationalized if the result after rationalizing is going to look simpler. We're going to multiply this by root 3 over root 3, a form of 1. The numerators multiplied will be 6 root 3. The denominators multiplied, root 3 times root 3 is just a 3. And this is why it will look simpler, because the 3 can divide into the 6, and overall it comes out to 2 times the square root of 3.